So chain rule, t squared plus 2t to the fourth, the whole thing cubed, clearly a chain rule. You bring the 3 down in front, leave the stuff alone, stuff's going to get squared, times the derivative of the inside, which is 2t plus 8t cubed. Everybody okay with that? Nice and easy, feeling good? Alright, derivative of cubed root of stuff, I would probably first write as stuff to the 1/3 power. The 1/3 comes down in front. The stuff is now raised to the negative 2/3 power times the derivative of the stuff. If you did not put the derivative of the stuff in parentheses, please be sure to do so. The parentheses are non-negotiable. Oh, you got a Bobo marker. It's bleeding all over you. Alright, so that's good as an answer. Also good as an answer would be 20x cubed minus 3, and then the denominator, the 3, and then the cubed root of all the stuff squared. I'll take either one. How many guys just earned your chain rule sticker? Nice. Alright, exponential function sticker. Let's see how we did here. Derivative of x to the e, x to the e minus 1. Derivative of e to the negative x is negative e to the negative x. Derivative of e is 0, because e is a constant. The derivative of x e to the x, this is a product rule question. So 1 times e to the x plus x times e to the x. Okay, next one. Quotient rule. Low, d high, minus high, d low, low, low. No need to simplify in any way, shape, or form. All the friends doing okay? Okay. Trig functions, derivative of sine of stuff. Cosine of the stuff times the derivative of the stuff. So cosine of x cubed minus 4x times 3x squared minus 4. Now, if f of x equals cosine of square root of stuff, you're going to do a double chain rule. This is one of those big mama problems. Derivative of cosine of stuff is negative sine of stuff times the derivative of the stuff is 1 over 2 square roots of x squared plus 1 times the derivative of that stuff, which is 2x. How many guys would have just earned your trig function sticker? Okay. Alright, log functions, natural log of stuff. 1 over stuff times derivative of stuff. Again, I need parentheses. Chain rule problems. I need to multiply by all this stuff here. You need parentheses. Number 2, now I'm just being mean. Polygon, how would you read this problem? I'm not even interested in the answer, but how would you read it?
Log of sine of x.
One more time?
Log of sine of x.
Natural log of. So as soon as you see this, you need to know chain rule, not product rule. Natural log of sine of x plus polynomial, keep going.
Sine of x and log of x.
Sine of, right? Chain rule, chain rule. 1 over sine times cosine plus cosine of stuff times 1 over x. That's the log function sticker. If you get both problems right for chain rule, you picked up your sticker. Exponential function sticker, trig function sticker, log function sticker. That's the next 4. How many guys are into all 4? 3 out of 4. Okay. Alright, moving on. Combinations. These are some nasty mothers. Getting any one right in the section gets you the sticker. If you get both right, you get 2 stickers. Is that the yay? Except she wouldn't actually say it. She would. Alright. Cosine squared. We've had this conversation before. Cosine squared means cosine of all the stuff squared. So this is like big chain rule. Stuff squared, it's 2 times cosine of my stuff times derivative of cosine, which is negative sine of stuff, times e to the x minus e to the negative x. These are some ugly problems. Stephen, you okay? The derivative of tangent is secant squared, not cosecant squared.
Secant squared, so couldn't you, I guess, simplify it to secant squared of x over 2
Secant squared. I'm so lost.
Because sine x over cosine x is tan x.
Oh, you're talking about number 2.
Oh, yeah.
You're so far ahead of me, I was back at number 1. Stay with me, son. I'll get us through this. Alright, so for the folks that think differently, like my friend Steven here, yes, you can absolutely rewrite sine of x over cosine of x as tangent of x. Such a good, smart, clever thing to do. We can get that. Okay, I would also hope that you'd rewrite natural log square root of stuff. You'd think about that p in front of the log property. And so you've got like stuff to the half power, bring the half down in front. So my answer is 1/2 natural log sine of x over cosine of x, and then I use my log properties. And then I just did my stuff. Yeah.
So we could have written it as 1 over tangent of x, root tangent x, like to start out?
Yes.
Okay.
Just put a little star next to this one. I'll check it myself.
Okay.
Okay? Yes.
And then cos squared of x equals negative sine of x.
No. Cosine squared of x is 1 minus sine squared of x. Okay? I'll check this one. All right, combining rules level 2. F prime is going to be cosine of the stuff times pi times a x to the a minus 1. If you get that right, you earned a sticker for combinations level 2. To get 2 stickers, now you need to do some quotient rule nastiness. Low d high, ax to the a minus 1, minus high d low, negative sine of bx to the c times b times cx to the c minus 1 over denominator squared. You've got both. 2 stickers here. How many guys got both stickers? How many guys got one of the stickers? I can get one of the stickers. Got at least one. All right, hopefully these went better. Derivative of x squared e to the f of x, clearly, product rule. Derivative of x squared is 2x times e to the f of x. Plus x squared, now take the derivative of e to the f of x is e to the f of x times f prime of x. Sticker earned. Derivative of square root of f of stuff, well, derivative of square root is 1 over 2 square roots of stuff. The derivative of the stuff is f prime of this new stuff times the derivative of the last stuff. Okay? Figure out how many stickers you've earned, meet me in the back of the room.
I got all my stickers.
You got all your stickers, but it's possible you earn 2 stickers in a couple of these places. Come on up, friends. I want to get rid of some of these stickers.
No, I tried.
Okay. Chain rule, exponentials, log, trig. No one has a sticker going in this column here, inverse trig functions. We haven't done any, but we haven't done that yet. That's coming. Combining derivative rules level 1, you can have 2 stickers, 2 stickers, 2 stickers. I'll leave my work. Look like somebody.
Yeah, if you got that. Is it level 3 too that you need 2 stickers?
Yeah, level 1, level 2, level 3, you get 2 stickers each.
I'm actually getting sleep now, but I'm more tired than before. And I didn't get sleep.
Okay. So while you guys are getting stickers, tomorrow I'm going to be staying after school from 1:30 to 2:30. Sorry, North Central and East End. I mean, if you guys want to show up, you'd be more than welcome. The more the merrier. But that will be a good time to work on, quiz corrections from the take-home quiz this weekend, because some of you guys have some scores that I know are going to make you want to throw up. What else? Would be a good time to work on any stickers that you are missing back there, because that counts as a quiz grade back there. You want to make sure that you're doing well. Lewis, here you go. Yeah.
I didn't know we had to do this one, so I didn't do it. So I'll be able to make it open.
Yeah, why don't you plan on maybe staying tomorrow so we can... All right, hi there. Andrew, you're over there. Don't confuse me like that. Celeste, Aaron. I'll just put it over there. Okay, Giselle.
Sorry, Lana, you're in my way.
Steven. Okay, Carmen. Things happen. You were clearly so embarrassed you didn't even put your name on it. It was that bad. Didn't even put her name on it. Halimon. Myra. It was very confusing for me, Carmen. I kept going through all these papers and I was like, oh, this must be David's. It doesn't have a name. I'm like, oh, no, David put his name on it. I'm like, oh, it must be Palamon. Then I ran out of boys and I'm like, what?
Right? You should just see the handwriting.
No.
And Lewis, here you go. And David over there. All right, if we could speed that process up a little bit, that'd be a good thing. And Stephen, we are filming, right?
We are.
All right. So we are going to go big brain. I am so excited. I have truly never taught this lesson before. I am optimistic that it is going to go well. If it goes badly, that's okay. I'll get to teach it 2 more times with the AB kids. And I'll eventually stick the landing. So, I know we still got people working on stickers. Okay, there's 2 things that I need us to know. When we're dealing with inverse functions, we're talking about like f of x and g of x, where g of x is the inverse of f. There was a new derivative rule yesterday. Lewis, what do you know from the video that you watched?
V prime of x is equal to 1 over f plus 5 f prime of x times g of g.
Careful, it's not f prime times, it's f prime of. So if you have inverse functions f and g, where g is the inverse of f, then g prime is 1 over f prime of g of x. That was like one of the new ones. And then the other new one yesterday was arc tangent. Arc tangent, this is new for the AB friends. The derivative of arc tangent of x, you guys know is?
Oh, is it 1 over, 1 over x squared plus 1.
1 over x squared plus 1, or 1 over 1 plus x squared. Now, eventually what's going to start happening is we're going to start looking at the derivative of like arc tan of stuff. Right? And as soon as I said that word arctan of, you guys keyed in right away and you know exactly what's going to happen here. What's going to happen? Derivative of arctangent of stuff. Chain rule. And what does the chain rule tell me to do? The derivative of the mama, so this is going to be 1 over, it used to be 1 over x squared plus 1, this has to be 1 over f of x squared plus 1. That's taking the derivative of the mother function, leaving her baby alone, don't stop, times the derivative of the baby, which is f prime. That's one of the inverse trig functions that we need to know. There's 2 more. There's only 2 more. And what I want to do is I want to go through and develop these as best we can. In the event that we get to 9:20 and things are not going well, we're just going to stop the show. And I'm going to ruin the fun and just tell you what the derivatives are. Okay? At 9:20. So at 9:20, Andrew, can you give me the face? What does the face look like? You look constipated. Oh, you're like, all right, at 9:20. Now, yesterday when we were playing around with derivative of arctan, we actually started by looking at the graph of arctan, and then we started talking about the derivative. So we're going to start in a different place for arc sine and arc cosine. We're going to start by looking at the graph of sine and build the graph of arc sine, which I don't think is something you guys ever did last year. At best, you might know what it looks like when you type it in on the calculator. I want to build the arc sine function. So if this guy up here is the graph of sine of x, and this guy here is arc sine of x, or sine inverse of x, I want to keep in mind that there's an inverse relationship here, meaning that if there's a point, for example, like, oh, what's this highest point up here in the sine of x? What are the coordinates here?
Wait.
Careful, the coordinates.
Pi over 2.
Pi over 2, 1. Where does this point go on the inverse function? Right? The inverse function, you switch. So where does it go? Pi over 2 comma 1 should get mapped to 1 comma pi over 2. So find where x equals 1 on here, and unfortunately the scale is too small for me to like see. So 1 is all the way over here. Pi over 2, is that this guy here?
No, it's
This one? This guy here? So this is the point 1, comma, pi over 2. Real quick, find a couple of other points that you know for sure have to be on the arc sine function. So for example, 0, 0. Oh, that's boring. When I switch those points, those are the same. Okay, how about this point over here? What is this? Negative pi over 2, negative 1. So that would get mapped to negative 1, negative pi over 2. There's 3 points, but there's more. Maybe you want to start going for some non-traditional points. Maybe you want to think about, like over here, what is this? Pi over 4, square root of 2 over 2. So I'd go to square root of 2 over 2. Well, square root of 2 over 2 is like 0.7. And then I'd go up. So this would be the square root of 2 over 2, comma, pi over 4. There's a point over here at negative square root of 2 over 2, comma, negative pi over 4. I'm just plotting some points. I'm taking points that I know for sure on this graph and graphing them over here. Well, I could also take a point like pi comma 0, and that would get mapped to 0 comma pi. I could take a point like this guy over here, negative pi over 0, and that would get mapped to the point 0 negative pi. And if you actually connected all those points, you're going to see something that looks like that. That's the graph of the arc sine function. I just lied to you all.
It's not a function.
Oh, that's
One more time?
Not a function.
Why not?
It doesn't have to.
This sucker fails the vertical line test. Truly what would happen if you did this point by point thing, what you'd have is you'd have your sine function just going like forever vertically up and down. Are we okay with that?
No.
So not a function. So what you wind up doing, the rules when it comes to the inverse, you pick a part of the graph that you know for sure will be a function, and it represents all your possible domain values. So I'll say that one more time. I want each domain value to be represented one time, and I want to make sure that what I pick is a function. So for example, what if I said,
Oh, so from.
let's take this part that starts over here, what was this? This was negative 1 comma negative pi. And where do I stop?
That should be probably.
Pi over 2, yeah?
So, yeah. And then 1 pi.
Do I stop here or do I keep going?
No, it's not that.
If I keep going, then I no longer have a function, right? The graph of the arc sine looks like that. It has the same sort of curving that the sine function does. It's just we're thinking about it going vertically rather than it going horizontally this way. This is the graph of arc sine. Not to be confused with graph of the derivative of the arc sine, which is what I want you guys to come up with now. You got my help in building the graph of arc sine, get me the derivative of arc sine. I have faith in your smarticle particles. Man, look at all sorts of stickers. I'm gonna have to go to the sticker store.
So.
Fine, 18's like that. David, what's up? You seem very confused when I said sticker store. That's okay. That usually happens with us, right? inflection.
Wait a minute. Where's it downward?
Increasing in that down.
Yeah, it's positive. It's positive. But it's wait, but it's concave.
You're smart.
Isn't it concave? Does this count as concave?
Does what count as concave down?
From zero, I mean from negative infinity to zero.
Oh, I don't know anything about negative infinity.
Or from pi, from -1, I'm sorry. to
From
zero.
-1 to 0 concave
Does
down?
that count as concave?
Absolutely concave
It
down.
doesn't like.
And I was drawing this graph in an exaggerated kind of fashion so that you'd see it. Think sine, but vertical versus horizontal. So I agree, we are concave down from -1 to 0, so that means down here.
We are.
If this guy is concave down, then the derivative graph has to be decreasing. I can also say that my purple graph is always increasing, so my derivative graph is always positive. We can talk about concave up over here, and if I'm concave up over here, then I have to be decreasing over here? Oh, how about increasing over here? That's good. All right, some people notice like a point of inflection, right? Because you've got a change in concavity. You went from concave down to concave up, which means my derivative has to go from decreasing to increasing. This is a relative min. No one has talked about, at least not that I've seen, what happens at -1 and +1.
Oh yeah, you're right. Yeah, you're right.
And what I'd encourage you to think about is where do these points come from? 1 comma pi over 2 comes from pi over 2 comma 1. -1 negative pi over 2 comes from negative pi over 2 negative 1. What happens with the tangent lines here and here? The tangent lines here and here are oh so awkward.
Where you're saying like what is it?
Where my markers are?
They're horizontal.
The tangent line is horizontal here and tangent line's horizontal
They
here,
become vertical.
which means they become vertical here. So you have a vertical tangent line at -1. Vertical tangent, vertical tangent. So in my derivative, let's see if we remember all these derivative rules from last unit. If f, the inverse sign, has a vertical tangent, the derivative has a vertical asymptote. I have a vertical asymptote here. I have a vertical asymptote here. You guys told me my graph was always positive, right? I'm always going to be above the x-axis. Decreasing, min, increasing. If I'm going to obey the rules of vertical asymptotes, my derivative graph will have to look something like that. Okay? Now, here's the thing. Sad news.
No, that's a smiley face.
That's a smiley face, true.
Let's just think so.
Sad news though. This is not a parent function. This is not one that you know. It's not one that you see. So, although I've got some good graphical evidence, what we don't know yet is what actually is the derivative for arc sine. So, let's see what we can do. We're going to build it. Stephen, can all the friends at North Central and Eastern see from over here?
Yes, they can.
Okay, so the goal is to find the derivative of arc sine of x. This is the thing that I want to know, but I have no idea what it is. Except for all the folks that made a foldable and you're like, I know what it is. Yeah, I know. Okay? So let's start with this. I'm going to let g of x be the arc sine of x. And its inverse function, the one that I am familiar with, is sine of x. Are we okay that these two are inverses? Because they're inverses, we have a derivative rule that we get to use here. Because these guys are inverses, we get to say that g prime is, what was it, 1 over f prime of g of x? All right. G of x is still arc sine, ugly. But f prime we know. What is f prime? F prime is cosine of x. Oh, so if I want to find the derivative of g, it's just 1 over the cosine of arc sine of x. That's the derivative rule. Not done yet. This isn't where we stopped yesterday with arc tan. This would be an ugly derivative rule. If you look back at your notes from yesterday, what we did here is we said, let's look at this arc sine nonsense to say, oh, you want an angle, so that when I take the sine of the angle, I get x. We built a triangle. Well, what's that triangle going to look like? That right triangle has right angle there. Sine, if the sine of theta is x, then the way I'm going to set up my triangle, sine is opposite over hypotenuse, opposite over the hypotenuse. I need this side length. Yeah, I was afraid this was going to happen. Lewis, what you got for me?
Square root of x plus 1.
Not square root of x plus 1. Take a minute, do your Pythagorean stuff here. You know this side length is what we're calling x. You know the hypotenuse is 1. Pythagorean theorem says this guy squared plus x squared equals 1 squared. So what's this? Not x squared minus 1. Not square root of x squared minus 1. Write it out. This guy squared plus x squared equals 1 squared. Solve that equation for this side. Right? This is the thing that I don't know. What squared plus x squared equals 1. Subtract the x squared. Take the square root. So square root 1 minus x squared. This guy here is the angle. What I need is a way to represent the cosine of the angle. The cosine is adjacent over hypotenuse. So that means that my final derivative answer is just going to be 1 over square root of 1 minus x squared. So derivative of arc sine is 1 over square root of 1 minus x squared. Before we do anything else, why don't you guys use your calculator skills? Let's make sure that I'm not lying to you. Have your calculator graph the derivative of arc sine. Let's make sure that it actually has the shape. Okay? Then, graph this function. Make sure it actually is identical. Make sure I'm not lying to you. I know it kind of looks like the cosecant graph, but it's not the cosecant graph. So the best way to do this, have your calculator find derivative of arc sine, like graph that function. Sketch on your same calculator 1 over the square root of 1 minus x squared. And apologies for not giving you guys enough room for some of the even Michael Jordan missed a couple of shots. If any of you take calculus BC with me again next year, I'll give you more room. What? Just in case you want to take calculus BC again next year, I'll give you more room then, I promise.
Hey, we come back.
It's gonna be so much funny.
Oh my god, good stuff, good stuff.
Oh, you can give me your card for that.
Okay, fine, do that way. Huh? I've got 1 minute before I get the face. Okay, did it work? Are you getting, you're getting the exact same thing? You can't find your calculator. Oh my, thank you. I'm just gonna leave her. Yeah.
Question, how can you not find it?
I have no idea.
Okay, did you get the exact?
Probably the part.
So I see that you graphed 1 over the square root of 1 minus x squared. Now, did you also graph the derivative of the arc sine of x?
I like big part.
I was like,
Okay,
right,
that
12
makes
meters.
more sense.
This
It's easier to in school.
is my answer, this is my own
That's
answer.
actually the big part.
Alright, well, I think some of you have been able to convince yourselves on the calculator derivative of arc sine of x is 1 over the square root of 1 minus x squared. Others didn't get a chance to convince yourself on the calculator because can't find the calculator, calculator's charging, God only knows what's going on there. Okay, here's the thing though, is everyone willing to accept in your heart that the derivative of arc sine is 1 over the square root of 1 minus x squared? Okay, good. Alright, so if you're willing to accept that in your heart, then derivative of arc cosine, we don't have time for the development. I'm just going to tell. So I'm going to ruin the show and tell part here. Stephen, feel free to keep doing your thing, and when you're done, let's see if we get the same thing. Alright. So let's wrap these up and then we'll get some practice problems. This is going about the way that I thought. This is why I've always avoided inverse trig functions before. Alright, derivative of arc sine of x, you guys know, is 1 over the square root of 1 minus x squared. So derivative of arc sine of f of x?
1 over
1 over
square root
1
minus
f of x squared
times the derivative of f of x.
times the derivative of f of x. Just chain rule stuff, right? You either know or you believe the derivative of arc sine is 1 over square root of 1 minus x squared, and then you just apply it. Derivative of arc tan of stuff, Polymon, what do you got for me?
One over x squared plus 1.
Okay, but it's arctan of f of x. We've got something more complicated. So 1 over f of x squared plus 1 times f prime of x. Now, I'll tell you, sometimes I'm going to write 1 plus f of x, the whole thing squared, and I hope everybody's going to be okay. Right? It's that commutative property in addition again. Now, here's the thing that you didn't know. The derivative of arc cosine. Stephen, have you figured it out yet?
No, it's weird.
Okay. Derivative of arc cosine is negative 1 over the square root 1 minus f of x, the whole thing squared, times f prime of x. God, how's anyone ever going to remember that one?
So complicated.
Ooh, how am I ever going to remember that derivative of arc cosine?
It's just the opposite of sine.
It's just the opposite. Stephen, if you had finished sketching out the inverse cosine graph and then looked at the derivative, what you would see in the graph, if the derivative of arc sine is a smiley face, the derivative of arc cosine is a frowny face. It's just the reflection over the x-axis. Okay. Everybody good with 3 new derivative rules? Okay. Here you go, model problem number 1. With the folks that are near you, show me what you can do. I have faith this is going to go well. I have faith. Not blind faith. Don't overthink it. If you've got 3 new derivative rules, now we're just bringing all the old skills out to play.
I thought it was 3. No, I'm gonna bet you gotta find the derivative of that.
Oh, isn't it the same thing?
Yeah.
Really?
Because this is a chain rule.
Mr. Hawthorne.
And we keep it the same for the derivative because the rule of the
We'll find out.
Oh, and then you multiply it times.
3.
Can I get some brave soul whose paper I can put up here?
That's right.
All right, Polymon, thanks for being brave. All right,
Times 3?
Yes.
let's take a look at Polymon's work here. It's going to be a little hard to read because he's writing in green.
Why are you writing?
I know, don't ask. The fact that he's writing, this is good. Okay, so according to Polymon, the derivative is 1 over the square root of 1 minus e to the 3x times e to the 3x
You
times
forgot
3.
to square it. You forgot to square e to the 3.
Okay, what's the mistake?
You forgot.
We forgot to, you said you forgot to square it. What did he forget to square?
E to the third power base.
E to the 3x needs to get squared because this guy here is the f of x. So the derivative arc sine of f of x, 1 over square root 1 minus f of x squared times derivative of the stuff, e to the 3x times 3. With all this in place, is everybody okay with this answer? How many guys actually have this as your answer? This is a great answer, but not the answer I will put on the multiple choice. I will hide it from you. How am I going to hide it? Celeste sees how I'm going to hide this. I'm going to be mean about this. You would never, ever see this answer. Lewis, how am I going to hide it?
You will e 3x times 3 over square root 1 minus e x 3.
Okay, one way I can hide this is to say 3e to the 3x over, I heard you say square root of 1 minus e to the 3x squared. Is that what you said? That's a way. I won't put that on the multiple choice. Neither will the College Board. They're going to do something else to hide this. There's one more algebra move. There's one more thing. They're going to mess with your head. Stephen, do you see it?
Wait, never mind.
I think you guys are going totally big brain and missing something obvious.
It's a square root of 1.
Yeah.
E to the 3x squared
Oh, yeah.
would be e to the 3x squared means e to the 3x times e to the 3x,
Oh, I mean,
which is
I mean,
e to the 6x.
yeah.
Square root 1 minus e to the 6x, I think, is the way that it would show up on a multiple choice test. All right, Polymon, thank you for your bravery there. All right, friends, show me what you can do at number 2. Hey, Andrew, can you tell me how would you read this problem?
Let f of x equal x times arctan.
I'm sorry, one more time, Andrew, in a nice, loud, proud voice.
Let f of x equal x times
X
arctan.
times, you say. X times. X times. So, product rule. And then arctan of square root of x. Oh God. Oh God. Chain rule. Kids at North Central are giggling now. Apparently they like to laugh in the AB class, and Mr. Simla looks over and he's like, what did Mr. DeRozier do this time? I got game. Shut up. Notation, polymorph.
You forgot.
Yes, I mean like notation, like use it.
You forgot like this.
The derivative.
You forgot all of it.
Product rule, derivative of the first times the second plus the first times the derivative of the second.
So this would be that. What can I just write?
x squared.
Oh, oh my god, I get the one.
Oh, that's a 1. 1 plus? F prime. Derivative of x is 1. Leave arctangent alone. Plus leave x alone. Times the derivative of arctan of stuff. 1 over 1 plus square root of x squared. Times, oh my god, derivative of the square root of x. 1 over 2 square roots of x. How many of you guys honestly have this as your derivative? Okay. Derivative of x is 1. Leave the arctan of the stuff alone. Plus, I need to see the plus. The first times the derivative of the stuff. Celeste.
Can't, for the second half.
Yep.
1 over 1 plus x.
Yes, for sure, square root of x, the whole thing squared is going to be x. There's other stuff you can do, so you might want to clean this up and say, all right, f prime of x is arctan square root of, that's an ugly square root, plus, what do we got here? X times this times 1 over 2 square roots of x is the same as x times 1 plus x, and then the denominator, 2 square roots of x. That's great. That has got to be a 2-point derivative for sure. Combining all those derivative rules, sadly not done. So sad, not done. Yeah, what we haven't done, Lewis, what haven't we done? You actually have to find f prime of 1, and yes, I am this mean. I want you to know what arctan of 1 is. 1 over 1 plus 1, 2 square roots of 1. Nothing interesting happening over there. But arctan of 1, the way that you're going to unravel this mystery is you change this to ask the question, tangent of what angle do I know of is 1. That's what an arc function means. Arc sine, arc cosine, arctan. Arctan of 1, tangent of what angle is 1? And this should be pi over 4. Okay. So your answer is, your final answer is going to be pi over 4 plus whatever this mess is. Is that 2? That's a 2. 1/4, so maybe a great answer, pi plus 1 over 4. Okay. Everybody was okay with the derivative? Okay. So we can do this last one. Alright, I'm just trying to bring back all these old skills to play.
I heard particle too. I was like, yes.
Triggered. Triggered.
Derivatives are looking good. It is just a channel.
No, you're supposed to tell me no.
It's never just a channel.
Right, arc cosine of stuff. As long as you know and you have accepted in your heart this new derivative rule, you know exactly what to do. It should just be -1 over square root 1 minus 2x, the whole thing squared, times 2. So -2 over square root 1 minus 4x squared. Hopefully that wasn't too complicated for anybody with the simplification. Quick show of hands, derivative. How are we doing? We got this? Good. Good. All right, now I want the equation of the tangent line, which means I need a point And I need the slope. The point, I can tell you for sure the coordinates are square root of 3 over 4. Now I need the y value. Think about how we're going to figure that out. I need the arc cosine of 2 times the square root of 3 over 4. 2 times square root of 3 over 4 is really square root of 3 over 2. Does anybody know arc cosine of square root of 3 over 2? In my old man brain, the way I have to get to arc cosine of square root of 3 over 2, I think, oh, cosine of what angle that I know of is square root of 3 over 2. If you need more help, I can see Myra. She's either praying or she's making her reference triangle. It kind of looked like you were making the sign of the cross there. I was a little worried. Okay, cosine of what angle is square root of 3 over 2? The cosine is the adjacent side. What's the angle? What's that angle? If this is the square root of 3 over 2, then this guy here has to be a half across from 1/2. Uh-oh. Good thing Mr. Lane's not in the room right now. Across from the 1/2, think about degrees if you need to. 1/2 is smaller than square root of 3 over 2. Small side, small angle. So this is 30 degrees. If this is 30 degrees, then that's really pi over 6. Right? So the coordinates for my point are square root of 3 over 4, comma pi over 6. Now I need the slope. So the slope is going to be negative 2 over square root 1 minus 4, square root of 3 over 4, the whole thing squared. Whew. Square root of 3 over 4, the whole thing squared. Square the numerator. 3 over 16. Multiply by 4.
3 over 16 is 12 over 16, which is 3/4.
3 over 16 times 4 would be 12 over 16. 12 over 16 is really 3/4. Subtract from 1.
No, it'd be negative.
We had 1 minus, this was 3/4 over here, so we've got 1/4.
Negative.
Not negative.
Oh, wait.
We were at 1/4. Square root of a fourth. 1/2. Negative 2 divided by 1/2. Should be negative 4. That's your slope, your final answer, tangent line, L of x. Where we have negative 4. X minus square root of 3 over 4 plus pi over 6. That's the equation of your tangent line. Now, a cautionary tale for all my friends in the room. If we're talking about the free response part of the test, don't bother simplifying. Right? This is all numbers. If we're talking about free response part of the test, don't simplify. Nobody cares what our cosine of square root of 3 over 2 is on the free response. But on multiple choice, I need to do it together. Okay, here's what I want you guys to do tonight for homework. Alright, if you look on pages 37 and 38, there are, out of 2 through 7, I want you to pick 4 of these. I don't care which 4.
We're skipping one, right?
Skip number 1, it's a pre-calculus question. So pick 4 problems out of 2 through 7, and then 3 multiple choice questions. There's 3 multiple choice questions on page 39, pick 3. The brain likes choice, you can can do them in any order that you want to, I don't care. Okay? So on pages 37, 38, pick 4 problems, 39, do all 3. I'll do the person. And then we're actually done with unit 3. Tomorrow you have a take-home quiz. Friday we have an in-class test. Tomorrow I'm going to stay from 1:30 to 2:30 if you want to work on quiz corrections from the one from this past weekend. If you have stickers that you're missing, we can do all the things that we need to do tomorrow from 1:30 to 2:30. Quiz corrections are due the day of the unit test, but tomorrow is the day I can stay after school. Okay? You guys all going to the college fair this afternoon? Okay, so do me a favor. If you happen to see me at the college fair, just walk by me, pretend we don't know one another. They'll be like, Dad, Dad. And I'll be like, move on. Okay. Don't jump on my back. See you guys later.
I'm not trying to hurt you.